First off, I'd like to welcome everybody and hope you're starting your new year off uneventful as far as no emergencies and keeping yourself safe from COVID. With that being said, then I'd also, as Renan said, we have people from all over the world that are participating in today's webinar. So I'd like to welcome you. So good morning, afternoon, evening, from wherever you are watching and attending from. I want to thank you for taking time out of your day to spend with us, and hopefully I can give some additional information on lithium-ion batteries and their hazards. Some of my background, I was originally a career firefighter. I retired back in 2011, and during the course of my career, I became and did as much educating myself as I could on the hazards, hazardous materials. I trained to the level of a hazmat specialist and ran a 17 community mutual aid hazmat team in and around the city of Detroit. And I was also a regional hazmat team leader within the state of Michigan. So once I retired, I wanted to use that knowledge to hopefully make firefighting a safer profession, and thinking that, hey, in the 21st century, there has to be a solution to deal with some of the high hazard fires that we face on a daily basis. And in my search, I came across hazard control technologies and F500. And through this presentation, hopefully we're going to share with you a little bit about F500 and how it's able to deal with the emergencies we're going to talk about, lithium-ion batteries. So with that, I'd like to start the presentation and let you know that HCT has been around since 1997. So we're not a startup company. We've got a lot of history behind us, a lot of testing, environmentally, globally, in all areas of the world where we are present. As you can see from our distribution, we do have locations worldwide where we can get it. Hopefully, my objectives today are going to show you how we can help your department, your groups that you may be working to protect your industry, your business, more efficient in being able to deal with lithium-ion battery fires. And in order to do so, I'm going to have to define and explain to you what a spherical micelle is and how it works, because that's the basis of an encapsulator agent, especially F500, and then how it's able to safely extinguish lithium-ion batteries, as well as reduce the toxic HF gas that's being released. And we're going to encapsulate and reduce the hazards of that water runoff that would be mixing with the electrolytes, and then identify percentages for the different classes of fires, and we'll cover those as we go through the presentation. So with that, I'd like to start on lithium-ion batteries. What are they? Well, they're a very good energy source. They're a renewable battery that basically you can charge. You have that positives, the cathodes, discharging and recharging, and in the process they can create some heat, especially when we start talking about that rapid discharge. They're a great source of energy because they will maintain that use power until almost the end of its charge, and then it's just a rapid drop off, unlike when we used to use our nickel metal hydrides or some of our other battery technologies, where you would start out using a tool, you'd start out using something, and then it would gradually slowly discharge. The lithium-ion batteries don't do that. So when we sit there and we start looking at the lithium-ion batteries, there's many basically 6 current lithium chemistries that are out there, and I'm sure there's more being developed. But these different batteries, as you can see from the top, we've got these abbreviations, and when you get this as a recorded, you'll be able to see these. But you have like the specific power and specific energy and things like that, and it'll tell you whether or not they're high, medium, or low as far as the use and the cost. So people are trying and working towards making these lithium-ion batteries more affordable, holding more power, so that in cars we can go longer distances, or with our phones, we can do more with our phones for longer periods of time. And when we sit there and we start looking at it, what are the concerns? Well, our demand is continuing to grow, and we're finding their uses and their replacement of other battery technologies constantly being replaced. And in the process of, as I mentioned, currently there's 6 types, but in reading and following some of the articles and some of the magazines, you'll see that, we're working on, and groups are working on other chemistries for these batteries. And some of the hazards are the toxicity, the gases that are emitted when they burn, the HF gas or the flammable electrolytes, and being able to deal with those, as well as that energy that's stored within the batteries. And we're going to talk about all the different classes of fires, because it's not just the batteries that we're dealing with. We're also dealing with the containers that the batteries may be in, and I'll discuss these different classes a little bit further into the presentation, but just something to be aware of. It's not just the hazards that the batteries possess, but pretty much all the different components. So when we look at what starts the fires, it's short circuiting can be one of the issues where, by a short circuit, the battery becomes unstable, it fails. A trauma, batteries being dropped, I'm sure all of us at one point or another have dropped our cell phones, power tools, etc. Overcharging, we can sit there, and if a charger fails, or there's safety devices that are built into some batteries, but like anything, these safety devices can sometimes fail as well and allow a battery to be overcharged, causing an overheat condition. And I'll point out again, when we use our cell phones, if you're out in your car and you're leave your car sitting on maybe the console or up on the dashboard while you're working on some paperwork, I'm sure you picked up your phone and you've had that message overheating, and it's got to cool before you can before you can use it. So we get into those overheating conditions with these lithium-ion batteries as well. And I wanted to show a quick video
involving one of Tesla's cars with an autopilot feature. The car slammed into a tree and burst into flames. Police tell ABC News it appears no one was in the driver's seat. Here's ABC's Gio Benitez.
Tonight, mystery surrounding a deadly crash near Houston involving a Tesla Model S. The charred wreckage captured on camera after it crashed into a tree and burst into flames. 2 men inside were killed. The Tesla's high-energy battery reigniting over and over again. Firefighters trying to put the fire out for 4 hours with more than 30,000 gallons of water. The fire eventually put itself out. Now tonight, the question, was the Tesla running on autopilot? Firefighters found the men in the front passenger seat and the back seat. Police telling ABC News there's no indication anyone was in the driver's seat. Authorities.
Okay. While the video goes on and starts talking a little bit about, the cause and things like that, the things that I wanted to point out in the video is, here we had a vehicle that was possibly on autopilot, crashed. The safety devices, while yes, they're there, they can fail when we have that impact, when we have that crash situation. Now we come into 30,000 gallons of water. We come into 4 hours, and when we sit there and we start learning more about this particular one, it was that basically it still burnt itself out. And I'm going to discuss some of the issues with this particular story a little bit further, but I just want to point some of those things out because I'll be discussing them as we go through the presentation. So when we sit there and we start showing this video, I want to point out that we're looking at these lithium-ion batteries be adopted in many different locations, many different industries, not only in our homes with our laptops and our power tools, but let's start looking at them in like I say, our automobiles. What are the dangers? I mean, they're continuing to grow. I hear people say, let them burn. Okay. Is that truly the answer? We have to take into account, if we're going to let them burn, what kind of an impact is it going to have? For instance, here in a lab, here in a warehousing situation, when we sit there and we start looking at the high lows, I'm going to ask, when we sit there and we start introducing these batteries into our homes, into our industries, are we prepared? And I'm hoping that I can give you some guidance and maybe open up your eyes on how an encapsulator agent can help with those decisions. So the popularity of this lithium-ion battery in electronics and transportation, especially transportation-wise, the use of lithium-ion batteries is just growing exponentially every day. You're hearing about, more auto manufacturers using them, and we hear a lot about the cars, but we don't hear too much about, how about the large trucks, the semis? How about school buses? How about some of these other vehicles? You don't hear much about them. They're not really in the news. That manufacturers are starting to look at that, and not only that, but even some farm equipment now, airports. And as we go through, we're going to see where some of these can have an impact on everyday life. Our electric and our hybrid vehicles, our charging stations. Let's think about the parking garages, dealerships. Not only that, but how about the repair facilities where if that vehicle is involved in an accident, it gets towed to. Our electric tools and our parts suppliers. And then again, the towing companies that are going to be dealing with those. And some of the things that I've been witnessing as I travel in some areas of the country, these are popping up like weeds in parking lots, these charging stations. They're, coming up in Walmart parking lot, shopping centers, they're in parking garages. And one of the things that I've always noticed when I take and I start looking at these is, one, I don't see any emergency electrical shutoffs, disconnects, any place within sight of these charging stations. And I'm hoping they have something built in automatically. But again, I'm not familiar enough with them to know. In the top right picture, you see the vehicle in a charging station in a parking structure. And I do not see any additional fire protection, any sprinkler systems. All we see is the required dry chem extinguisher hanging on the wall there in the red box with the yellow. So we're not saying that we're taking any precautions when we start adding these charging stations where these lithium-ion batteries are stored. And yes, I'm a firefighter, and I have to say that when we sat there and we started bringing our lithium-ion battery tools on board the vehicle, and yes, they do get dropped and abused, we're not doing anything to look at some type of a fire protection to be able to extinguish those batteries if they are to fail. So in many cases, it comes to a point of education. And one of the things that I'm going to, as we go through the presentation, talk about even more within the fire service and industry when we sit there and we talk about these batteries. So when we look at the aviation, we have our devices that help to load and unload vehicles, our ground equipment and ground handling equipment. Again, at the airports, our parking structures, the forklifts, and some of those other devices. These are all things that we're looking at trying to convert from, green, or trying to convert to green technology, because again, we're trying to make things more efficient. The problem becomes when we sit there and we start looking at these vehicles being charged, we look at how close into proximity each of these vehicles are. And again, when I show this picture, I don't see where any additional fire protection has been put in place. So you have these buses and these transportations. I mentioned earlier, our semis, tractor trailers now are starting to look at lithium-ion battery technology that they can use for making maybe deliveries within a community where they don't have to have the diesel exhaust when they're stopped and they're parked. And this is, again, pictures of some of the batteries and the size of them. As you can see, all they're going to do is get bigger and bigger as we try to make them so that these vehicles can go longer distances or we can drive them for more time. And I want to show this video because it's a good video. Here we are all of these vehicles parked on charging stations in the close proximity. So while we have the vehicle burning, you could hear the force, the velocity of that fire. Rather impressive. And now you have that fire which is impinging on the vehicle next to it. I also point out the charging cables, again, being slowly but surely melted away by the fire. I don't see on the charging station itself or in the close proximity anywhere that I can see within this picture the disconnects. But the thing is that, you know, here now, as that vehicle sits there, you can see it starting to roll away. Even though there may have been brakes applied or, you know, whatever device that's used in the vehicle with an electric engine to stop, it rolls back. It rolls now, luckily not very far, but if that had been a little steeper, who knows where it could have rolled to and what it could have caused else to catch on fire. But I want to point out the car that's even further away, and I'm going to just jump ahead here a little bit. You see now as that truck starts to fail and those batteries start to catch on fire, they start impinging on the third vehicle, and you know, you have that chain reaction. So now let's think back to that rack with all the buses, or let's think back to the high-low that were so close to all the charging stations. So these are all things that, you know, I like to point out that we need to take into consideration if we're called as far as fire departments, or we start talking about the people that need to be concerned. Now that's pretty impressive fire that's going off. And one of the things I want to make a comment on with lithium-ion batteries in transportation. Most cases when lithium-ion batteries are being transported, they do not have a full charge on them. They're probably somewhere in the area of about a 30% charge. Now, I don't know what state those batteries were on this truck, but if these were new batteries being transported to a location to be installed in a vehicle or to be installed in a device, they more than likely have only a 30% charge on them. And yet look at the violent reaction that and the explosions that you're hearing as those batteries are popping and failing. It's quite the video. And then we sit there and start looking and we start beating up on aviation. I'm going to speed through this one, but you know, here we're sitting again trying to get our ground vehicles so that we use in yeah, that we're using. I'm going to speed this up so you can see where the batteries fail. But again, what's the most common extinguishing agent that we use? It's dry powder. So you can hear, you know, those batteries start to explode, and as they start to explode, the workers that were trying to use the dry powder to extinguish it, they start to run off and try to get as far away from that little ground unit as possible. And we're going to see another rather impressive explosion when it comes to lithium-ion batteries towards the end. But we just need to understand, when we sit there and start looking at these batteries and the amount of power and the amount of energy that they have, they can lead to some very powerful and dangerous explosions. When we sit there and we look at our consumer electronics, our cell phones, our laptops, in the house with our children, the gaming consoles, again, I mentioned power tools. A few years back when hoverboards were first coming about, we've seen and read about many fires caused by hoverboards, and now it seems to be e-scooters are taking over, as well as our remote control toys and battery backup systems. But these batteries, they come in all different shapes, all different sizes. And when we sit there and start looking at it, it basically boils down to how many amp hours, how much use we're going to get out of it. It may be a 20-volt battery, maybe 4 amp hours, it may be 6 amp hours, it may be 8. The size and the number of amp hours generally is going to dictate the size. The more amp hours, the longer that battery is going to last, the bigger it's going to be. And that comes true when we sit there and start looking at our power tools. And one of the other things that we like as a convenience, is to be able to have another battery all charged and ready to go when the first one that's in the tool currently is going dead, and it's no longer got enough charge to continue being used. So we get into our multi-chargers, so where we have multiple batteries that we have in our garage. And here we're going to see a quick video that is going to show a e-scooter. So a great example of how, when you start getting into that fully charged battery, here he was charging up the scooter. You hear that pop where something fails, and all of a sudden that e-scooter, gives off a lot of that HF gas and the toxic gases, and then we have that rather violent explosion. A laptop. I'm sure we've had and seen or heard of laptops. So here you have, a laptop charging. I don't know if it had been dropped previously or what type of abuse it might have suffered. Just sitting, charging, and it fails. Something went wrong. An e-scooter. You can see on the ground that he has tried to use some extinguishing methods. It looks like he used a dry powder as well as some water. Again, ineffective, and we will, as we go and continue on through the presentation, we'll start to look at all those different agents. So we now are looking at industry. Not only we looking at residential storage systems, people trying to get off the grid, trying to be less reliant on the power industry, using solar and saving that energy to batteries. We're looking at industrial storage systems, and then our mass storage systems, where we sit there and we basically power shave. We charge the batteries up during non-peak hours, and we use that power during peak hours to help power the grid, so that we're not reliable on others to try to provide or help provide energy. And some of the isolated incidents that we can talk about, here we have some that are in Europe and other countries where, a plane, because of a battery, burning is evacuated. We have a boat because of a burning battery, 5 are injured. And again, another airplane that's evacuated. In 2019, Arizona, a battery energy storage system. which exploded and caused injuries, some career ending for firefighters. Here most recently in April, that 21, that Tesla that killed the two, burned for 4 hours, 30,000 gallons of water. Then in December in Austin, Texas, we have a car that hit some gas pumps, and you'll see a video here shortly. And firefighters, hey, we need more training. And most recently, just here in January, we have an e-scooter that caused a 4-alarm apartment building fire and injured a firefighter. So these are starting to increase in the number of cases and incidents that we're having. This is a good video. It shows a high-low. And, one of the things that I point out, that I want to point out as we watch this video, what is the extinguishing agent that's required in our buildings? You get into our warehouses, you get into our factories, you get into our high rises, and the required extinguisher is a dry chem, an ABC type extinguisher. And so these employees are running around throughout the facility. They're grabbing these dry powder, the ABC extinguishers that are required by code. They're coming along, they're working to try to put out this fire. It appears as they start to use the dry powders that they're having some success. They're, getting a little bit of a handle on trying to extinguish this fire. However, you'll see their efforts are in vain. And we're going to go through and we'll see in videos exactly why. But you see that burst, that flare up, that fire flare up. And again, just like that truck that we saw, that started rolling away. Here we have the high-low. It also kind of rolls away, rolls further and deeper into the warehouse, burning the warehouse down, causing multi-million-dollar loss because they did not have the right type of an extinguisher. Those buses that I showed earlier on the charging stations, well, how about when they're at the terminal picking up passengers? Let's look at all the dry chem extinguishers that are on the ground. Again, that's what we require by code. When we sit there and start looking at our building codes and our different codes. So again, I throw the question out. Are we, let's put it this way, not only you, but are we prepared when we start talking about these hazards? So let's start with that dry chemical. Why doesn't it work? Well, it doesn't remove the heat. It's very inefficient at being able to cool. It can't stop or prevent a reignition unless you can build up a pile deep enough to bury it. It does nothing to reduce the toxicity of the gases that are being released. So it's very ineffective on being able to extinguish these types of fires. And I'm going to show a quick video with the powder. This is showing, the 182 lithium-ion, the 18650 cells, the round ones. It's charged up to 48 volts. It's 95% charged. We're sitting there and using that dry powder. And as you can see, it is very ineffective on being able to extinguish the lithium-ion batteries. Okay. When we sit there and we start looking now at foam, what is usually after firefighters use water and water does not seem to be effective, our next go-to is usually foam. And this testing that was done, I'm going to mention more of it as we go through. The testing that was done in these videos are coming from testing that was done on behalf of HCT Europe and Johnson Controls and trying to find third-party independent testing on a solution for lithium-ion batteries fires. So these are videos from that testing. When we sit there and start looking at foam, again, it doesn't do anything to remove the heat. What do we do at night when we're cold? We pull up a blanket. Well, what do you think a foam does? It forms a blanket. So what do you think it's really doing to the heat? Little to nothing. Doesn't do anything as far as stopping that reignition. Because if you do have a little bit of an effect with the foam blanket's going to break down. The heat's still going to be there. The fuel's still going to be there. It's reigniting. And again, when we start looking at the toxins, the gases, the hazards of the electrolytes, we're not doing anything. We're not having any type of effect on those. So when we sit there and we look at the video that was done showing foam being tested, again, the same number of batteries, same charge, 95%. We start using foam, and as you can see, there's no effect. As you can see, he's constantly spraying that string of foam trying to extinguish the batteries. The next thing, and this is one of the things that we see recommended for a lot of those energy storage containers, is an inerting gas. They use a few different types of agents. And again, we point out that while these inerting gases may be useful in some instances where we're maybe doing like switch centers or some applications within, the some of our industries, again, they do very little to cool, and they cannot stop thermal runaway. So the possibility for reignition, once that inerting gas is released from the room or the building, the structure, where it's been activated, once it's released, again, you've got the heat, you're going to have the gases, the toxins, and everything there. And this is the case which happened to the Arizona firefighters. While the inerting gas, might have extinguished the visible flames, it did nothing as far as cooling and stopping the thermal runaway. So when they opened up the container, and oxygen started to enter into, or air started to get into the container, it hit that air fuel mixture. It was just right. The heat was there. We had an explosion again, injuring some firefighters that were career ending. So again, not an effective extinguishing agent, especially for some different types of uses. And this is a video. This is at NASA in one of their labs. They're working on a robot. Luckily, the engineers that were working on it happened to head off to lunch and weren't there when this battery failed. But we have a person that comes in because NASA understood that dry chem wasn't the solution, so they have an inerting gas. And as you can see, the inerting gas is very ineffective. It has little to no effect at all on being able to extinguish this lithium-ion battery. He comes in with a second one. Again, I want to point out that he's exposing himself to that toxic gas. And I'm going to mention that a little bit more as we continue on through the presentation. But while he does have somewhat of an extinguishment, if the video goes on, it does reignite. We do have a reignition of the battery. And the fire department comes along and actually removes that battery from the lab. So the next thing we are very familiar with is water. And with everything that we see published here in the United States, the answer for lithium-ion batteries is copious amounts of water. And, when I was going and doing all my training in the fire service and learning what I could about hazardous materials and all the other things, I hear copious amounts of water many times through my training, and it's always a head scratcher because how much is a copious amount of water? The video I just showed you earlier in the presentation showed 30,000 gallons of water for one car fire. 30,000 gallons. Is that a copious amount? is that going to put out a tractor trailer fire? Or when we start talking about those buses and some of the high-lows or some of the other fires that we're talking about, are we going to start needing 60,000, 80,000 gallons? What's a copious amount for those types of things? So that always, kind of gets me a little leery and on edge when I hear a copious amount. Again, when we use water and we hear of water being used, we hear of reignition. Okay, hours, days, and weeks later, we have these reignitions. So when water is used, we still aren't safe as far as that battery not having or not being a hazard. Water doesn't do anything to reduce the toxins, the HF gas, and again, that electrolyte. So I start now then talking about, as we look at our environment and trying to clean things up, if we're using 30,000 gallons of water on a car and we've got that electrolyte that's in the HF acids and things like that that are involved, where's all that water going off to? What's it doing to our environment? Are we going to now have to sit there and try to contain 30,000 gallons of water before we sit there and start putting these car fires out? What's going to take place? So when we sit there and start looking again, here's that Tesla on the left, but we have another one.
Image of the Terrytown Shell station at 1:21 Thursday morning. An instant later, this is the moment when a Tesla sedan slammed into the car. Flames from exploding lithium batteries created an orange glow. The driver, who was not immediately identified, survived, but was charged with DWI. When the gas pumps fell, flames coming from the passenger side of the Tesla can be seen. About a minute later, sparks erupt as more batteries ignite in what's called a thermal runaway. It was a situation Austin firefighters were prepared for, according to Division Chief Eddie Martinez.
We've known about these for quite a while. It's just in the city of Austin, as far as I know, this is our first one, specifically with the Tesla.
This picture shows fire crews in tactical positions for what was a long fight. The fire burned all the way to the car's frame. But lithium batteries can play possum and reignite. A warning, Martinez says, was given to the tow truck driver.
And it did. So 5 hours later, the car caught on fire again. But he took our warning and he put it away from vegetation. He put it away from other vehicles, so it didn't catch anything else on fire.
The fire that happened here is expected to be discussed during a training session that Austin firefighters will have next week. That class will be taught by the fire chief from the Woodlands, who's become somewhat of an expert on Tesla fires.
These car fires can be managed. We're going to see a lot more of them in the future.
Chief Palmer Buck told me this fatal crash in April is an example of how difficult the job can be. It took more than 28,000 gallons of water to keep the charred battery pack cool. That allowed investigators to work without having another thermal runaway.
Just doing all the research, it still comes back to the basics of water, but a lot of water. There's not any, at this point, any easily obtainable extinguishing agent on the market to deal with these fires. And it all goes back to the way the car is engineered, with the battery pack being the bottom of the car and encased in a titanium shell. So you really can't gain access to it. You just have to sit back and pour water on it.
In Terrytown, Rudy Koski, Fox 7 Austin News.
So this is why I'm glad that you've all joined us for this webinar today. Because as you can see, here we have people that are going and calling themselves experts. And, again, I'm not trying to bash anybody, but when you sit there and you look at the trainings that we have here in the US, the solution and the answer is for the fire service, copious amounts of water. We haven't looked at anything other than, and that's why Europe is light years ahead of us, and why HCT is wanting to do these webinars and offer trainings to firefighters so that we can sit there and we can work. And I sit there and I show this video, nice little waterfall trickling down, water trickling on down a little stream, because when we sit there and I again talk about 30,000 gallons of water on one car. You look at the second Tesla there in Austin where it hit the fuel pumps, and now you're dealing with two types of a hazard. You're dealing with a hazard of fuel as well as the batteries. And while, yes, many of these departments are saying they have fire hydrants, they have all the water they need, they don't have an issue with that. Many areas of the country, in the United States and even around the world, there's many areas that are going through drought conditions. So now I'm going to ask again, do you truly have an extra 30,000 gallons of water for one car? And as these batteries get bigger, are we going to be able to deal with them and be able to control them? What's a copious amount of water? So as we've seen what other agents and what other types of extinguishing mediums have been able to do with this type of a hazard and emergency, let's start learning a little bit about F500 and encapsulator technology. And one of the big things when we start looking at firefighting agents or solutions, we're trying to get away from PFOS, PFOAs. We're trying to get away from fluorinated ingredients that are going to the forever chemicals. And F500 has been tested and is 100% fluorine free. It's non-corrosive and 100% biodegradable. We're not going to stay in the environment. We're not going to be a forever chemical. We're listed as a multi-class AB fire suppression agent and a combustible, flammable, vapor, and liquid spill agent. And I like to point out, can anybody name for me an extinguishing agent that can work on combustible or flammable vapors, preventing an explosion? Well, here we have one. So it's, as it said, a multi-class. To understand what an encapsulator agent is, we first need to have a little bit of an understanding on the molecule. And here's a video.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic non-polar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the non-polar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The non-polar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
Okay, so that gives you a little bit of a understanding of what a spherical micelle is. And again, I'm going to kind of review what we just saw. That molecule has a polar head, loves water, okay? A non-polar tail hates water, does everything it wants to get away from the water, which is one of the ways that when you add encapsulator, a 500 encapsulator agent into water, it mixes instantly because of those tails trying to get away from the water. So it spreads out and mixes with the water rapidly. So once it mixes and it creates those spherical micelles within the water, as that water comes out of a nozzle, a sprinkler head, or whatever source it's being utilized from, those molecules on this outer surface of the water droplet, they spin away from that spherical micelle. So ones on the surface, they break apart and they form a skin on the surface of the water droplet. So when we start looking at some of the different classes of fires that we're going to be talking, that becomes important as to why it's able to rapidly cool, why it's able to rapidly extinguish, and how it's able to do all the things that we're going to continue to talk about as we go through the presentation. But one of the things I want also to point out in this picture, if you look at the very, very last water droplet to the right, you'll still see that there's millions of those spherical micelles in the water droplet. So we're not only putting a skin on the surface, but we still have millions and millions of those spherical micelles inside of each and every water droplet, which is important to help understand how encapsulator agents work. So I'm going to talk about encapsulator agents and how they're able to work on the flammable electrolytes and why they're able to work on those flammable vapors. Okay, because of how and why they work. We're going to talk about that rapid reduction in heat. And if we think back, if you're a firefighter, very first day you started school, you learned about the fire triangle. If you remove one of the legs of the triangle, of course, I'm dating myself when I say triangle because now it's a tetrahedron. But if we remove one of the legs, we extinguish the fire. Well, we're going to see how we're able to encapsulate the fuels, how we're able to rapidly reduce the heat, and how we're having to have an effect on all the different parts of that fire tetrahedron. This is a picture of a battery that went into thermal runaway and was extinguished with a 500 encapsulator agent. You'll see the battery cells, the 18650s to the right of the picture. Those are ones that have failed. F500 was used to extinguish the batteries, and all those batteries to the left are still somewhat in their packaging. They haven't caught on fire. They haven't continued with the thermal runaway. This battery's been extinguished. And I will say, when F500 has been used to extinguish a battery and all the testing that's been done, there's never been a report of a reignition. We have not received any indications. Some of the other things that we are going to talk and look about is the reduction in toxins. Okay, the HF gas that's being released, how it can be life-threatening, especially let's go back to the gentleman that was in that lab with that CO2 extinguisher, the inerting gas. How about the gentleman in the house when that e-scooter, you saw the amount of smoke that was being released from those batteries. So we're going to talk about how F500 is able to do that rapid cooling and how it's able to stop thermal runaway. I'm going to talk a little bit more about by being able to do that rapid cooling and by being able to encapsulate those flammable electrolytes, we're going to reduce and eliminate the chances for reignition. And then the toxic gases, how we encapsulate and reduce the amount of toxic gases being released. So I want to show this video, which is comparative testing. I know I showed videos that were side by side earlier. Here you have, again, the powder in the middle of foam, and to the far right, F500. And when you saw the first video with the foam, you saw that they were constantly using a spray. It was a constant application. When you sit there and you start watching with the F500, you'll see he's using short little squirts. He's not using a constant application. He's, short little squirt. He's getting into a little bit more of an application right there. But he's pretty much extinguished this battery. Now, on the left, you'll see with the powder, as he came into view, he did not have an air pack on. Okay, so this initial testing that was done with these lithium-ion batteries led to that gentleman who was doing the extinguishing spending some time in the hospital detoxing because of the HF gas that he was exposed to when he was doing the testing. Now, because of that, we'll discuss that more, but testing then went indoors and was a little bit more thorough in looking at other things. So this is absolutely one of the things that came out of the published report for Johnson Controls, and it basically states that powders are poor, not recommended, do not apply on lithium-ion batteries. Okay, yet what is, again, I'm going to throw that out there. What's the extinguisher we have in all of our buildings? What's the one that's required? We look at foams, moderate to poor. The remarks, not recommended, don't apply on lithium-ion battery fires. And then we get into the F500 with all the testing that was done. Recommended, use F500 on lithium-ion battery fires. And this is right out of Johnson Controls, the largest fire protection company in the world. In Europe, they found a solution. In fact, they're marketing and through one of their suppliers, one of their distributors. They're marketing fire extinguishers and have literature and pamphlets out there that recommend F500 encapsulator agent as the agent of choice for lithium-ion batteries because it could stop thermal runaway. And again, some more conclusions that a handheld extinguisher with F500 additive is better to achieve suppression with these lithium-ion batteries. So that's why they're marketing them. We've seen the videos with the 18650s, and when we sit there and we hear about these fires in the news with Teslas, Teslas are 18650s. But I want to point out that that is not the only type of battery being used in vehicles. Here's an example of a polymer pouch style battery that might be in a laptop. Now, one of the things I want to point out, as you see, the sides of the pouch are what open up, and that electrolyte and the flames come out of the side pouch of that battery. Yet, when we sit there and we look at the application of the F500 solution, it's landing on top of the package. It's not entering into, but it's landing on top, but yet it still has that ability to cool and being able to extinguish with just the overspray getting into. Another example of a polymer pouch style battery, the spray as the battery fails is going to hit the top of the plastic structure. As it sprays, the overspray is basically going to spray off and hit the top, and you're going to get some of the overspray that extinguishes this battery. So you can see, some of the splashing and the overspray is what's really doing and having the effect on being able to extinguish. This is some of the indoor testing that was done. This is going to be a somewhat long video that I'm going to speed up. There's multiple things that I am going to point out as I do go through the video. If you look at the top left picture, you're going to see some whiffs of smoke that will come off of the battery as it starts to heat up. We have our thermal imaging camera that's going to be on the top right. And then on the bottom right, we've got some thermocouples, some temperature sensors that are going to monitor temperatures within the battery. So I'm going to go ahead and start this, and I'm going to, as we go through, kind of explain what's going on here a little bit. But you're going to see, as we start speeding up, the thermal imaging camera is going to start showing some heat building up. I'm going to speed it up here a little bit more. That top left, you'll see the little whiffs of smoke starting to appear. We're starting to get, a little bit of heat building up. Still really not that hot. Our little whiffs of smoke are starting to get a little bigger there. You'll see the smoke there, and very soon we should have that ignition. As you can see, we have ignition take place. We have thermal runaway beginning because that one battery is now going to start the batteries next to it and catching them on fire. So we're going to continue on moving through. We'll see those temperatures continue to rise on some of these sensors, and I will point out they're in Celsius. So if you look at number 5, I point out, that's pretty good temperature sensor there on the bottom right to watch. We're getting up into like 600, 650 degrees. we have F500 being applied, and look how rapidly that temperature drops. I mean, within a matter of seconds. I'm going to back it up so you can see it again. You're going to, in just a matter of seconds here, go from in excess of 600 degrees Celsius down to 17 degrees Celsius in seconds. So a copious amount of water or F500. You see how little was used. As we continue to go through and move forward with this particular video, you can see that there's no increase in temperatures. As we continue through, some of the sensors, some of the thermocouples that were used have failed, but as we continue and go through, you will see that none of those temperature sensors are starting to rise, showing that the heat's building up and it's getting ready to go into reignition. So once that battery's been extinguished, it is no longer a hazard as far as worrying about it reigniting. Some of the other information, as I mentioned earlier, that gentleman with the first few videos using the different dry powder and foam and F500 without an air pack and having to spend some time detoxing, that then led to some additional testing to find out, and this was done by T.L. Claustel University. And one of the things that they were looking out in the testing is the HF gas that was being released. When we look at the parts per million on the right, it was without trying to extinguish, no extinguish water. You'll see that in one of those little 18650 cells, you're about 227 parts per million. And we started getting into the bigger polymer pouch style batteries. You're looking at about 56 parts per million. But when they sat there and they used F500 solution to extinguish the battery, look at the drop in the parts per million. Look at the drop in the HF gas. The highest for a polymer pouch style battery was 37 parts per million, 37.45 parts per million. And in the 18650s, it was 1.8 parts per million. So, you know, we sit there and start looking at NIOSH, we start looking at our different guidelines for acute exposures. You know, hell, you got 30, excuse my language, you got 30 minutes at 34 parts per million. That gives a person a chance. You know, if you've got somebody that's been injured, you're giving that person some time. You're giving that person a chance to survive an exposure and not have any health effects. And when we sit there and we start looking at that reduction in the HF gas, it now sits there and starts bringing up another topic, you know, because I mentioned earlier, it's not just lithium-ion batteries that are burning when we start talking about automobiles, it's other things. And this is some information that we have that was done by university, Clemson University. And what it was is when, you know, they were watching some of our earlier videos of fires, black smoke turning white, the question was asked, what's happening? And so this test is kind of a indication of what was taking place. They used toluene as their fuel source, and they were spraying 3% F500 solution through the smoke column. And they were looking at three things. They were looking at light transmission through the smoke column. They were looking at the amount of soot that accumulated, and then the toxicity of the soot. And when they sat there and they got all done, the report came back that, wow, they were able to reduce the smoke and increase the visibility by 68%. They were able to reduce accumulated soot by 97%. But the toxicity of the soot and the smoke is 98.6%. So when we're sitting there and we're looking at everyday fires in the fire service, not just our lithium-ion batteries, but we look at cancer in the fire service because of all the synthetic materials that are being utilized in homes today. And here you have an agent that can reduce soot toxicity by almost 99%. Again, it goes along with the lithium-ion and the HF gas and all the classes of fires that we're going to see in our cars. You saw the Tesla hitting the gas pumps. Okay, well, again, you're going, we could have multiple fuels that are involved with these accidents, with these hazards. So we look at all the classes of fires that we can be used on. Class A fires are normal combustibles, Class B, flammable liquids, Class D, lithium ion. Now, who's ever heard of using a water agent on a Class D fire? So tires. I mean, we sit there and as firefighters, we know tires can be, especially when you have a lot of them, a difficult fire. They create a lot of heat. They're a nuisance. They can be out there and fighting them, again, like a lithium ion battery. You could spend many hours trying to fight a tire fire. Especially at some place where they're recycling or having a large amount of these tires. So they're difficult, they're stubborn. Yet F500 has been used on two of the largest tire fires in North America. We look at Class B materials, our fuels, our polar solvents, ethanol, alcohols, and other things that are going up and down the road, and how we're able to be used to mitigate spills and extinguish these fires. And I'll note that, if you look at F500 in the National Contingency Plan, we're listed as a surface washing agent. So we're listed to be used on these types of incidents as far as being able to control spills. I mentioned just a minute ago, Class D metals, like water additive being used on a Class D metal. It's unheard of. If you look at the standard, no water when it comes to Class D metals, but yet I can sit there and point you in the direction of some Class D metal manufacturers, some die casting companies that are using it and absolutely love F500 for use within their facilities and dealing with Class D metals. So we look at automobiles. There's now roughly on average just over right around 350 pounds of magnesium in most of our vehicles. That's on average, because they're looking for lighter weight, strong materials. So the solution, okay, education. Okay, it was mentioned there with the Tesla hitting the gas pumps, the fire departments. We need education. Okay, well, we hope to be that source of education. We want to be able to come out and train fire departments, employees on the hazards of lithium-ion batteries, to share the information from all the testing that's been done so that we can sit there and again, as I said earlier, make firefighting a safer profession. Okay, if we look at the F500, it's not just Johnson Controls that has done the testing. We have Bosch, we have Teslas, we have basically leaders in the industry that have standardized when it comes to a solution for lithium-ion batteries. So you have mobile and fixed. We offer these carts in two different sizes with an inline ejector. So you have fire extinguishers with 2.5 gallon or 6 liters. We call our quick attack mobile units. We have carts, compressed air systems, different sizes that can be utilized to help with the extinguishing. We have partnered with Fire Rover as well to help with some unique applications and being able to offer fire protection.
Fire Rover is the revolutionary way to stop fires before they begin. Using military-grade thermal cameras to detect abnormal heat variations and up to 20,000 gallons of firefighting agent, Fire Rover protects your business from property loss and downtime. Here's how it works. The thermal camera detects changes in surface temperature. Abnormal heat triggers an alarm and alerts Fire Rover's live monitoring station. Trained operators evaluate the risk and can trigger the firefighting agent remotely within seconds. Operators aim the firefighting agent using both thermal and HD footage. The firefighting agent is 100% biodegradable and effective on metals, petroleum, plastics, agriculture, rubber, general waste, and more, including lithium-ion battery hazards. Fire Rover can reach a distance of 150 feet with a radius of 343 degrees. The thermal camera confirms when the fire is extinguished and the surface has cooled, eliminating the need for costly fire watch. Fire Rover is always ready to detect and extinguish fires and keep your operations safe. Contact us today to start protecting your business.
And that pretty much picked on some of our recycling industries, but these systems can be utilized wherever they need to be, where you need to have monitoring taking place. And as it shows, we have other options, which we call our concentrate control, which is your normal that you often see in many high hazard areas, as your bladder tank construction to your tank. One of the things that we are liking a little bit more, and we're kind of recommending now because it's a little bit more efficient. It's a little bit more cost effective as far as maintenance and overall usage. It's our diamond doser water driven proportioner. And then, as you see on the bottom, these water-driven proportioners can feed and supply multiple risers to protect multiple areas of the plant without having to have redundancies in systems or having to put a bunch of the concentrate control systems in. This is going to be, again, recorded and shared with you, so you'll be able to see this information and read through it here as we are. But like I say, we have multiple systems. We're more than willing to work with fire protection contractors in including encapsulator agent in their systems to protect some of the high hazard applications that they may be faced with. But I'm getting ready to end, and I'm going to again, say that, when you look at encapsulator agent, yes, we're here. We want to encapsulate the world. We want to make it a safer place. We want to be able to help with those high hazards. And as it says, we want to be a leader in the industry around the globe. And just to give you an idea, these are some of the companies that we're already helping to protect. So we, by all means, would enjoy and be happy to assist. And I'm going to kind of end with a video here, because I talked about that truck that was 30% charged. Here's a fire truck, believe it or not, lithium-ion battery powered. But you can see the explosive power when you sit there and you start dealing with a large battery pack in a vehicle, what type or what you can expect. So, I end and want to say thank you all and say, it's time we wake up. It's time we look at the solutions. Okay. And to us, it's very important as far as our company that we be involved. We are part of and members of NFPA. We have people that sit on NFPA tech committees and help contribute information in trying to change standards to include encapsulator agent. We're ISTA contributors. We work with Society of Fire Protection Engineers. So if you are members of or work with and you would like us to come and present at one of your monthly meetings, please feel free. We'd be more than happy to come and present. And lastly, we are very proud of the fact that we are an ISO 9001 registered company. Quality control is very, very important to us. Well, what we can do is, if you've got, people that you want to share this training with, and hey, contact us. As we said at the very beginning, one of the things that we want to do is we want to get out there and train people. We want to get out there and get the message out there. So by all means, if this is something that you want to share within your group, your community, your organization, contact us. We'll be more than happy to make the arrangements so somebody from HCT can participate, and that way we'll be able to answer questions that they may have for you as well.